Alrighty, let's go ahead and go over 2.23. I am going to be veering a little bit away from exactly what is being done in the illustrative math curriculum. So I'm still calling it 2.23, but it is not going to match up perfectly with what you find inside of the online book if you ever go there. What I am doing now is we are looking at compound inequalities when you have a single variable. The start thinking part was just trying to get students to be able to work backwards rather than having a situation and needed to write out a inequality. I'm giving you the inequality and I want you to come up with a situation that would be modeled by this. So when we have 5x is less than 100, I said that that was $5 a hat and you need to spend less than $100. The x plus 30 is greater than or equal to 75. I said you need at least 75 points and you already have 30 points. The next one is you're buying records for $30 each and you've already spent $100 and you could spend at most $500. So the students came up with their own in class. A lot of them had some kind of variation of what I did, like the first one, A being a certain cost per item and spending less than 100. But it's nice to be able to go both ways, get a situation and write the inequality and then go the opposite way. So this application right here, we were talking about income and how much taxes you pay at the federal level. We talked about that the first certain amount of money you make is only taxed at 10%, then it goes to 12% for the next amount, and then for the next amount it goes to 22, then 24, and so on. They're called tax brackets. So I believe it is going up to $11,600 of income, you're being taxed at 10%. So every dollar you make, you only have to give 10 cents to the government. Then between 11,000 and 47,000, this is if you are unmarried, you'd be paying 12%. And then over 47,000 up to whatever it is, 100 is I think 22%. And basically you have tax brackets. So your money is not all taxed exactly at the same exact rate, but each different segment of it is going to be taxed at a different rate. So in this one, it says income that is more than $11,600 and less than $47,150 is going to be taxed at 12% by the federal government. Marcus already has made $11,000 for the year and he's making $300 per day. How many days can he work where the income will be taxed at 12%? So what we did here is we wrote out two inequalities. There were two different parts here. You had to have the income being over 11,600. You had to have the income being less than 47,150. So what we did in A was we wrote out our two inequalities. The money that he has is the $11,000 plus $300 times the number of days. And we had the same exact thing on the other inequality, but just one was greater than 11,600 and the other one was less than 47,150. So the question was then, does your solution have to go along with one of those qualifications or both of them? And the answer was, it has to go along with both of them. It has to be over that amount and under the other amount. So it is both, and that is called an and inequality. We've talked about how efficient mathematicians can be. And some mathematicians saw this set of two inequalities and goes, oh, I could probably combine those so that I have to write less stuff. So as you can see in C, you can write those two inequalities as a compound inequality. If you ever see an inequality with stuff in the middle and stuff on the two sides, that's going to be an and inequality. So we had the 11,000 plus 300x in the middle, and then you had the thing that it had to be bigger than on the left and the thing that had to be smaller than on the right. So that thing is called a compound inequality. Then, rather than solving two inequalities, what's cool here is it allows you to solve the middle part of the inequality, and whatever you do to the middle, you just have to do to both sides, and it's like you were solving two different inequalities. So the first thing is subtract 11,000 from both sides. Then you have to divide by 300 on both sides, and you end up getting x is less, or 2 is less than x, which is less than 120.5, aka x is greater than 2, but less than 120.5. That's talking about the number of days that he's going to be working where his income is going to be taxed at 12%. So it says, give an example of a number of days where that day he's going to be paying 12% on his income. Well, any number that is greater than 2 and less than 120.5 is going to be taxed at 12%. So one of those answers was 30 days, another one was 52 days, another one was 120 days. 2 is not, because this is not x is greater than or equal to 2, it is x is greater than 2. So there we go. You can see that there are many different solutions this is talking about. If it is written in that form, it is an and inequality, and then we would graph it. So these are basically two different inequalities you're graphing. You're graphing that x has to be greater than 2 and x has to be less than 120.5. So you can see I have noted each one of those inequalities on your number line, and I used arrows to represent it. We said that it has to have both of those characteristics to be a solution. So it only makes sense that and problems are going to have overlap. So you can see where the two arrows were overlapping. I went over and shaded the number line. And any one of those numbers on the number line is going to represent a solution, a number of days where the income coming in would be taxed at 12%. We then went to another problem. This one is a little funky. It's kind of hard to come up with these problems so that they make sense for and or inequalities. But this is talking about the fact that water, it says water is liquid above 0 degrees Celsius and below 100 degrees Celsius. You do not want your water to be liquid. You want it to be either ice or you want it to be steam. It says the water is about to be subjected to a temperature change that will increase the temperature by 35 degrees Celsius. I put this little side note and I talked to Mr. Olson and I talked about how when you're talking about steam gets to 100 degrees and then it kind of stays at that temperature, which is interesting, but we are going to ignore it for this problem. So the first part says ignoring the temperature change that is about to happen, right? Two inequalities that represent when the water will not be, that's funny. I said when the water temperature will not be water. It's supposed to say liquid. When the water temperature will not be liquid. So when we're looking at this, the two times it's not going to be liquid is when it's less than or equal to 0 or when it's greater than or equal to 100. The question then becomes, does it have to have both of those characteristics or can it have either one of them? And the answer is it can have either one of them. If it is below 0 or above 100, then it is not water or it's not liquid and we don't want it to be liquid. So once again, it looks like I repeatedly say, does the water need to meet both of those constraints to not be water? That is supposed to say liquid. I'll have to correct my note packet before I save it. So anyways, that was supposed to say not liquid. Next, what we are going to do here is you're not going to write or inequalities as like a compound one like we did before. You keep them separate and you write the word or in there. We changed it now to bring in the fact that the water was about to be heated by 35 degrees. So I said x plus 35 on both of them. And then I had the same exact symbols, the less than or equal to and the greater than or equal to symbols. And when you solve these, you find out that your temperature before you do the heating up by 35 degrees would either have to be negative 30. It says x has to be less than or equal to negative 35 degrees. That's when you're starting. Even after it heats up, it's still going to be ice. And then the other one is it has to be greater than or equal to 65. And then when you add that extra 35 degrees, then it is going to be greater than or equal to the 100 degrees, which makes it steam. When we go over and graph this, though, if you graph it, you do not need to have overlap. Any of the numbers that are going along with one of those requirements is going to be enough. So if it is going to be less than or equal to negative 35 or greater than or equal to 65, that will work. After we did that, the students went over and just took some different abstract problems and we solved these. Remember, whatever you do to the inside, you do to both the left and the right. If you ever multiply or divide by a negative, you need to switch your sign. So on that first one, when I solved that, I found out that all numbers that are greater than or equal to 7 or less than 21 are going to be solutions. And you could see how I graphed it with an open versus a closed dot and then my arrows and did the shading where the overlap was. I did the same exact thing for the second problem. The only thing with this is when you divided by a negative, you had to switch your sign. Now, really, the smaller number should be on the left when you write a compound inequality. So that should be negative 10 is less than or equal to x, which is less than 7. It's better to write it that way. And then the overlap would be your solutions. And then when we solve the other or problems, you end up not needing any overlap. So I graphed that, and since they were both greater than or less than, it was open dots for both of them. Now, for your homework, when we jump into the homework, you have your graph here, and you're supposed to be figuring out what could be the compound inequality, either an and problem or an or problem. You can see that number 1A is going to be an and problem. It's going to have to be greater than a number, but less than a different number. So I made sure to say x had to be greater than, notice the mouth is opening towards the x, -4, and it has to be less than or equal to 3. And any of the numbers that are between those are going to be solutions. The next one is going to be an OR problem. So x can be less than or equal to -3, or x can be greater than 1. And that would be the compound inequality. The next problem here is saying that Karen has just finished learning about solving systems using substitution, elimination, and graphing, and she remembers that there are times when a system has infinitely many solutions. She is asked what the solution of 2x plus 1 is greater than 11 is, and she was kind of daydreaming, so she just blurted out, infinitely many solutions. Explain why she's technically right, but why the answer doesn't narrow down the actual solutions. So when you think about this, think about all inequalities. If I say x is greater than 2, how many numbers are true for that? Infinitely many. When I say x is less than -1, how many numbers are less than -1? Infinitely many. So just saying infinitely many is not good enough. You have to tell me what part of like infinity, how do we divide this up? How do we find out what the solutions are? So it says most inequalities have infinitely many solutions. There are some inequalities that are a little bit funkier. We'll talk about those. And then when I say the true infinity that you're talking about would be all numbers greater than 5. So if you solve that and subtracted 1 and then divided by 2, you get x is greater than 5. So yes, it's infinitely many solutions, but it's only the ones that are greater than 5. The next one, once again, these are really hard problems to figure out that make sense and can be compound inequalities. So the first one is the mail trucks won't leave unless they have 100 pieces of mail, but it can only hold 700 pieces. You already had 50 pieces. So the mail coming in, x plus 50, has to be greater than or equal to 100, but it has to be less than or equal to 700. And that's an AND problem. Reason it's an AND problem is because it has to have both of those characteristics, over one thing, under another. The next one is kind of a funny one. It's basically saying that you get a discount if you go to a concert and you are under 10 or if you're over 62. And it was saying that you are going to go to a concert in 2 years from now. What could your age be right now so that you can still get a discount? So you're saying whatever your age is, if you add 2 to it, it would have to be less than 10. And whatever your age is, when you add 2 to it, it has to be greater than 62. It's not an and. I may have just accidentally said and. It's an or. Either one of those. You get a discount for being young or older. The next one is talking about mules at the Grand Canyon. It says the mules can get a little nutty if they can't feel weight on their back. So they need to have at least 50 pounds worth of weight, but they can't have any more than 250 pounds of weight. There's a saddle on there that's 20 pounds already. And then you have 2 twins that weigh exactly the same amount, and they are X pounds each. So if we represent how much they weigh or how much is going to be on the mules, it's going to be 2 times the weight of each twin plus the 20 pounds for the saddle. That needs to be greater than or equal to the 50. Notice the mouth is opening towards the 2x plus 20, but it also has to be less than or equal to 250. So that would be the inequality. We then went over and just solved some basic ones. You subtract 1 from both sides. Then you divide by 4. You never ended up multiplying or dividing by a negative, so you end up getting the -6 and the 3. The next one, you add 3 to both sides, which does not make you switch your sign, but then when you divide by a negative, you do have to switch your sign. And I went over and moved it so that the smaller number was on the left. Your number is going to be greater than -6, but smaller than 9. The next one is an OR problem, so all you do is solve them independently, and you end up getting -3, x is less than -3, and x is going to be greater than 4. Remember just saying -3, that's no longer good enough because it's going to either be greater than or less than or greater than or equal to or less than or equal to. It then asks which one of the inequalities A, B, or C are -10, 0, and -3 going to be solutions. So as long as I did this right, which I hope I did, -10 is not going to fit inside of the answer for A. It's not going to fit inside of the answer for B because it's not between -6 and 9, but it is going to be either less than -3 or greater than 4, so it works for C. When you put 0 in, 0 is between -6 and 3. It is between -6 and 9, but it is not going to work for C because it is not less than -3 or greater than 4. And the next one, when you put in -3 is between -6 and 3. It is between -6 and 9, so it's A and B, but but it is when it says x needs to be less than -3. -3 is not going to work for that because it does not say less than or equal to -3 in number C or letter C. I wanted you guys to be able to graph these. So the first one, you had to have an open dot at -2 going to the right. You had to have a closed dot at 4 going to the left, and the overlap is your solutions. For the OR problem, you are going to go to -3, have an open dot, and go to the left. And then you are going to have go to 5, have a closed dot, and go to the right. And you do not need to have any kind of overlap. And then lastly, you had a little bit of review. The review was, can you get this thing into slope-intercept form? Making sure that you can see when you divide by a negative, you're going to flip your sign, and you end up getting y is less than 2/3 x minus 4. So you start at -4, go up 2/3, make your dotted line, and then since it's less than and it is in slope-intercept form with the y coming first, you can say that that is shade below, but really we should try 0, 0. If you substitute 0, 0 in, you'll have 0 is less than -4, which is false. So it cannot be the side with 0, 0. It's got to be the other one. Anyways, that's the lesson. Thanks for watching.